Hey everyone, my name is Shanu and I'm working in James Britain Noida as an assistant professor, and I'm here to give you a session on the topic start from data structure using C and C++. So let's begin with the topic. So Stack is purely used for linear data structure in modern computers, in which insertion and deletion of an element can occur only at one end, that is top of the stack, and it is used in all of the applications in which data must be stored and retrieved in the last. An everyday analogy of a stack data structure is a stack of like books on a tax, stack of a blades, table tennis, stack of bottles, undo or redo mechanics in the text editor, etc. Also, stack is a data structure in which all the insertion and deletions of entries are made at one end, called at the top of the stack. And the last entry, which is insertion, is the first one last. It will be removed. That is called as a last first out. And we basically call it as a refill. So a stack is an abstract data type commonly used in most programming language, and it is named stack and is behaved like a real world stack. For example, a stack of cards and a pile of the plates. Basically, stack is called as a stack because it behaves like a stack. Because in the real world scenario where the real world stack piles of books, as a stack is an abstract data type which is predefined capacity, which means that it can store the element of the limited size, and it is a data structure that follows some order to insert and delete the elements. That order can be before or before. So here is an example we can follow, and we can use like in the stack we have like we use last and first out. So basically, if we want to implement a stack, that can be implemented by using the array structure, pointers, linked list, etc. And a stack can either be fixed size or it can be a dynamic. Like we have multiple operations which you can do in the stack. That is like push. If we want to add an element in the stack, that we're going to use the push operation. And if we want to remove the topmost element from the stack, we have to use the pop operation. And then we have also her top, that is that top item without removing it. And we have also other operations like clear, is empty, size. So let's talk about the basic operations in the stack. Like we have an example is empty is equals to, we have like some elements like 5, 1, and 3. And we want to create. So like if you want to create like example, and if you provide a stack with having the elements 5, 1, and 3, and you have provided as an empty, and it will execute as a false, because empty means the stack is having 0 element. Basically, element will be an empty. Okay. If we want the top element will be 5, because in the stack we have the last in first out. Okay. And if we want to tap like here, because stack is empty, then we cannot like pop an element because there is nothing in the stack. So it will generate the error. So basic operations, we stack like we have to create a stack that it leaves it empty, then test whether the stack is empty. We have like the stack is full, return the size, and let's talk about the pushing and popping a stack. Let's take an example. Like we want to push a box in the stack. Okay. And now we want to push a B box in the stack. Again, I want to pop a box from the stack. That means if we want to delete file, and it will delete from the topmost element. Okay. Again, I want to pop an element from the stack, and that means the last inserted will be popped out. Okay, and here my stack will be empty. And if you want to push a box C on the stack, it will be inserted in the stack. And if you want to push box D, it will also insert it on the top of the C. Again, if you want to push another box E, then it will be inserted into the stack and it will be mounted on the top of the D stack. Here we have the you can use a constructor to initialize and create it stack as an empty. Like we can use this type of notation to create an empty. And we have to go for the pop operation, push operation. If we want to, like we have multiple steps to involve with we want to use in the push. Like before inserting an element in stack, we have to check whether the stack is full. Okay. And if the stack is full and we want to insert in that stack element, the stack is full, then it will be have a condition that can be called as an overflow condition. So first of all, we have to initialize the stack, then it will have to the value at the top as -1, check that the stack is empty or not. Okay. Then if you want to have an element and when the new element is pushed in the stack, first the value of the top gets incremented. That is, we have to increment the top pointer by 1. Okay, and then the next element will be placed as the new position of the top. The element will be inserted until we reach the maximum size of the stack. Here we have the push operation. If we want to push, here in the example, the stack is empty, so the top will be at the -1. And if we want to push 10, the element will be inserted at the 0th position. And if we again want to push 20, then top will be 1. Because every time when we insert any element in the stack, it will be incremented by 1. Okay, again, we want to push 30, then the top will be 2. And if we want to push 40, then it will be as a top is 30. And here the stack is full. And if we want to again try to push another element, it will generate as an overflow condition. Okay. Now we have a pop operation. These are the steps. If we want to do some pop, that means we want to delete from any element from the stack. First of all, if we want to pop any element from the stack, every time the element which is on the top most will be will be popped out from the stack. And if the stack is empty, then we cannot pop any element and it will generate as underflow. Okay. And every time whenever we want to pop any operation, the top will be decremented by -1. Here we can use an example for the top operation. Here we have the stack is full and the top will be as a 3. And if we want to pop out from the 40, because every time when we want to pop, the element on the topmost position will be pop out. Okay, and whenever we have again popped out and when we reach the lowest amount of the stack, then the condition where the stack is empty, the top will be assigned as a -. And if you want to talk about the working of an operation or the working of the stack, then first of all, we have to create a pointer that is called as a top, and it's used to keep track of the top element in the stack. When we initialize stack, we set its value to -1 so that we can check if the stack is empty by comparing top is equals to -1. Okay. On pushing an element, we increase the top value. Okay, and the place a new element in the position pointed by the top. On popping an element, we return the element pointed to by the top and reduce its value. That means we have to reduce top is equals to top -1. Okay, and before pushing, we check if the stack is already full, and before popping, we have to check whether the stack is already empty. Okay. And we have some advantages and disadvantages of the stack. If we talk about the advantages of the stack helps in managing data that follows the LIFO technique. Okay. Stacks are being used for systematic memory management, and it is used in many virtual machines like GPU. When a function is called, the local variable and other functions parameters are stored in the stack and automatically destroyed once written from the function. Here, efficient function management. Okay, and if we talk about the disadvantages of the stack, and the stack memory is of limited size. Okay, the total the size of the stack must be defined before. If too many objects are created, then it can lead to the stack overflow, and the random accessing is not possible in stack, because if you want to access any element, the element every time will be accessed by the topmost element. If the stack is false outside the memory, it can lead to abnormal combination. So thank you for my side, and thank you.